All right, so we know that in chapter 2 we talked about algebra. And when we talked about algebra, we talked about how to solve algebraic equations. What did we say we have to do when we solve algebraic equations? It's on the algebra vocabulary poster, and it's written in brown. What is it called? What do we have to do? It's above Addison's head, and it's written in brown. Nobody? Inverse operations. And what does the word inverse mean? Opposite. It means the opposite operation, okay? So anytime we are trying to solve an algebraic equation, we are using inverse operations or opposite operations, okay? So, on the left side of your paper, you can see that all of the equations on the left side are what kind of equations? They're all what? Addition. So what are we going to have to use to solve these addition equations? What's the opposite? Subtraction. So let's look at the first one. And I'm going to blow mine up so that it's easier for you to see. And I just want to look at number 1 right now. So if we have x plus 2.5 equals 7, we just said that in order to undo this addition, we have to do the opposite, which is subtraction. So what am I going to subtract? I want to get the variable by itself. So what am I going to subtract from here? 2.5. And remember, if I do it to one, I have to what? Do it to the other. If I buy something for Campbell, I need to buy something equal for John, because it's unbalanced if I don't, okay? If I give one person a sucker in here, I need to what? Do it for everybody so it's balanced. So if I do it on the left, I've got to do it on the right, okay? So on the left, what are we left with? We did nothing with the x, so we can bring it down, okay? Because we did nothing with that one. If we have plus 2.5, and then we take away 2.5, how much do we have? Nothing. So that cancels out. I can bring down my equal sign. Now I need to subtract. 7 minus 2.5. Have we done that before? Yeah, we've done a problem like that before, or 10, okay? So, can I take half from nothing? So what do I need to do? I got to borrow. 7's going to change to 6. And what do I want my whole to look like over here? 2. Because that's one whole, and I already had a 2 right here. So now, 2 minus 1 is 1. I keep my denominator the same. 6 minus 2 is 4. So x equals 4.5. We can check our work. 4.5 plus 2.5 should equal 7. Okay? I want you to work on number 2. I want you to work on number 2. I want to get x by itself. So what do I need to get rid of to get x by itself? Are y'all asleep? What's with the x, y'all? 1 1/5. Because it's plus, what am I going to have to do to get rid of it? Subtract. If I do it to the left, I have to do it to the right. On the left, what am I going to have? The x, did I do anything to it? Nope. I'm just going to bring it down. 1 1/5 minus 1 1/5 does what? Cancels out. Bring down my equal sign. Now, I'm going to rewrite this because I don't like the way that looks with that 3/10. So I've got 5 3/10 minus 1 1/5. Can I do it the way it is? No. I've got to do what? Find a common denominator. We have to ask ourselves the questions. Is the larger denominator a multiple of the smaller denominator? Yes. So our common denominator can be 10. Now, yesterday when I was working with A-Day students, one thing that kids were getting mixed up with was their equivalent fractions, okay? So if it helps you, take a Post-it note, take your hand, and cover up the second fraction, okay? To make sure that you are finding a common equivalent fractions. Do we have to do anything to 3/10? No, nothing. So I'm going to cover it back up, and I'm going to go to my second fraction. Now, how do I get from 5 to 10? Times 2. If I do it to the bottom, I have to do it to the top. 1 times 2 is 2. Now, can we do our subtraction? Yes. 3 minus 2 is 1. 5 minus 1 is 4. So x equals 4 1/10. All right, let's look on the right side at number 7. Is it number 7 or number 6? Let's see. 7. Thanks. Number 7 right here. I'm going to do it like this because y'all have more room over here. Okay, so we have x minus 5 1/9 equals 3 1/3. Or 3 1/3 equals x minus 5 1/9. What is the opposite or the inverse of subtraction? Addition. So I want to get this x by itself. So I'm going to have to add right here. I want to do the opposite. So what am I going to add? Whatever's there, 5 1/9. If I do it for one side, I've got to what? Do it to the other. These cancel out, and I'm left with what? X equals. Now, I don't like this over here. There's not enough room for me to work. So I'm going to rewrite over here. And you should have enough room over here that you can rewrite it. We've got to find a common denominator. Is the larger denominator a multiple of the smaller denominator? Yes, it is. So 9 can be my denominator. So let's cover up the bottom one. Just look at the top one. 3 times what is 9? 3. So 1 times 3 is 3. My bottom one, do I have to do anything to the bottom one? Nope. What operation are we doing? Addition. 3 plus 1 is 4. Keep my denominator. 3 plus 5 is 8. So your answer should be 8 4/9. I want you to work on number 8 by yourself. How many people got 12 19/20? Yes, ma'am. You better hurry. 12 19/20. How many people got that? Yay, very good. Okay, I want you to flip your paper over. Remember, we've talked about a lot in here that life does not come at you and say, I need you to solve this equation. 8 7/10 equals x minus 4 1/4. Does life come at you like that? No. You've never heard your parents talking that way, have you? Never, ever. It's always a real life, real world experience. And y'all, I would be doing you a severe disservice if we did not do word problems. And remember, I told you that by the time you leave me this year, you are going to be confident in the fact that you can do word problems. You might not like them, but because you know it's real life and because you know how to do it, you will have more confidence in doing it, okay? So let's read this one all the way through first. The difference between Christina's and Aaron's heights is 1/2 foot. Aaron's height is 4 1/4 feet, and she is shorter than Christina. How tall is Christina? So let's go pick apart our word problem. We know this word, difference, means what operation? Subtraction. Difference means subtraction. So we know we're doing subtraction. We also know that in math, the word is means what? What does is mean? My shirt is gray. Chase's shirt is red. Deaja's mask is black. That means it equals. That's what it is. There's no doubt. So is equals. And we know that over here, we've got 1/2 or 1/2 foot. Okay, does everybody see what we got so far? All right, now it tells us that we want the difference between Christina and Aaron. But the taller person needs to be the first person, right? So who's taller? Christina is taller because Erin is 4 1/4 feet and she is what? Shorter. So Erin, I'm going to put an E here for Erin, is shorter and Christina is taller. Do we know how tall Christina is? Nope. Do we know how tall Erin is? How tall is Erin? So I'm going to put that there. Now that looks kind of messy. So I'm going to come over here and rewrite it just so it looks a little neater. Is this something that we know how to solve now? Yeah, we've been doing this, right? So how can I undo that subtraction? I've got to add. And whatever I do to the left, I have to do it to the right. So I'm left with my C. Those cancel. I have my equal sign. Now, 1/2 and 1/4. Do I need a common denominator? Yeah, I do. What is it? 4. 4 is a multiple of 2, so we can use 4. One half. 2 times what is 4? So 1 times 2 is 2. The bottom one, we've got 4 and 1/4. Do I need to change it at all? Nope. So 2 plus 1 is 3. 4 plus nothing is 4. So how tall is Christina? How many of you plan on running track one day here at school? Nobody, not one person in here wants to be on the track team, be in an event, the 100-meter dash, 400-meter relay. None of y'all. What? I bet y'all might change your minds. Well, Jack is on the track team at school, okay? He decreased his first best time in the 400-meter race by 1 3/10 seconds. His new best time is 52 3/5 seconds. What is Jack's old time in the 400-meter race? So let's go back and pick out our key words. Jack decreased. What does decreased mean? Subtract. Okay, so we know we've got to subtract. He decreased his best time. So that was his first best time. Okay, so I'm going to put his old best in the 400-meter race by what? He decreased by what? What needs to go here? 1 3/10 to get his new time. What is his new time? Should I leave it with the words old best there? What should we do? Put a variable. What letter do you want to use? X. Okay. So I'm going to put X minus 1 3/10 equals 52 and, oh, wait a minute, 3/5. This is supposed to be a 5 right there. Now, I'm not going to go over solving this one, okay? You're going to have to do that one on your own. All right, does anybody have a question about solving these equations? All right, give me a